My name is Malida Vernandes Sasadara from Central Laboratory of Genetic Resource, Udayana University, Bali. So today I would like to present my research about the effect of extraction solvent on total phenolic content, total flavonoid content, and antioxidant activity of Bulung Sangu or Gracilaria species seaweed. There are several points behind this research. The first is that Bali has a type of Gracilaria seaweed known as Bulung Sangu. As a type of red macroalga, Bulung Sangu contains various active metabolites that can be used for health, cosmetics, or other fields. Our previous studies conducted to explore the biological activity of Bulung Sangu resulted that Bulung Sangu itself showed anti-cholesterol, antioxidant, and anti-inflammatory activity. So based on these points, we wanted to explore more of Bulung Sangu. Our previous studies have shown that the secondary metabolites in Bulung Sangu played an important role in providing biological activity. As we know, one of the secondary metabolites group that show potential activity is the phenolic groups, especially flavonoid. In order to maximize the extractions of phenolic and flavonoid, we perform an optimization of the extract solvent. We evaluate in which solvent produces the highest phenolic and flavonoid levels by the maceration extraction method. In this study, we use 4 solvents: water, methanol, ethanol, and acetone. Methanol, ethanol, and acetone are used in 3 different concentrations: 100%, 75%, and 50%. So we had 10 different types of solvent system to be optimized. We formulate the problem in this research in which one of the extraction solvent used produce the highest extract yield, phenolic content, flavonoid content, and antioxidant activity. Our sample was Bulung Sangu, collected in Serangan, about 500 until 1000 meters offshore, held by the fishermen. For the methods, we start from materials and sample preparation. Just like what I said before, the sample of this research was Bulung Sangu. Bulung Sangu itself is usually sold for consumption as a substitute of vegetables. Before being consumed, Bulung Sangu is soaked in calcium hypochlorite, or maybe we know it as caporate, and it then will become green and soft. For this research, we use fresh and red Bulung Sangu. And so the fresh and red Bulung Sangu was washed to clean the impurities. Bulung Sangu usually cooled on other seaweed, as shown in figure 1. This is the figure of Bulung Sangu that was cooled on other seaweed. All impurities must be removed, and Bulung Sangu washed under running water. We usually wash it more than twice to remove the salt. And figure 2 show the Bulung Sangu in which has been separated from other seaweed and impurities. Bulung Sangu was then chopped to reduce the size and make it easier to blend, and then oven dried at 14 degrees Celsius for 3 until 7 days until a constant weight was obtained. And the dried sample was then blended and shipped to homogenize the particle size, resulting in a coarse powder. And the next method is extraction. For the extraction, the Bulung Sangu coarse powder was then extracted by maceration. A total of 10 grams of powder sample was extracted with 20 milliliters of extraction solvent. The sample were stirred frequently and macerated for 72 hours. After maceration, the liquid was filtered with filter paper. The filtered were collected and vacuumed using a vacuum rotary evaporator. The next steps are determination of phenolic content and antioxidant activity. Total phenolic and flavonoid content were determined by using Volin, Schiosalto, and aluminum chloride colorimetry methods, measured at 760 and 450 nanometer using a UV-vis spectrophotometer. The calibration curve were established using gallic acid and quercetin. The antioxidant activity of the extract was measured with the DPPH method, measured at 517 nanometer using a UV spectrophotometer. And the half maximal inhibitory concentration of IC15 was reported as the amount of antioxidant required to decrease the initial DPPH concentration by 50%. For the results, we have extraction yield, TPC for total phenolic content, TFC for total flavonoid content, and IC15 for inhibitory concentration 15 or the half maximal inhibitory concentration. And the highest value for every variable are signed in red box, followed by the yellow box. For the extraction yield, the usage of 75% of aqueous methanol showed the highest extraction yield, followed by the usage of 50% of aqueous ethanol. For TPC, the usage of 100% of acetone resulted in the highest TPC, followed by the usage of 100% of ethanol. For TFC, the usage of 100% of ethanol resulted in the highest TFC content, followed by the usage of 100% of acetone. For IC15, the strongest antioxidant activity showed by the usage of 100% of ethanol, with the lowest IC15 value, followed by the usage of 75% of aqueous acetone. And the IC15 of the extract macerated by the 100% of ethanol showed lowest IC15 as compared to ascorbic acid as the positive control. This result indicating that the extracted by 100% of ethanol produce extract with stronger antioxidant activity than ascorbic acid. So according the result, we can conclude several points. Firstly, that organic solvent and water produce higher extraction yield as compared to either water or organic solvent without combination. This result may be due to their ability to facilitate the extraction of both components soluble in water and organic solvent. In contrast to extraction yield, the TPC, TFC, and antioxidant activity decreased with the presence of water content in organic solvent. As compared to other solvent systems, the usage of 100% of ethanol for maceration of Bulung Sangu is considered the most effective. This solvent produces highest TFC and strongest antioxidant activity and high TPC content, even though not the highest. That's all my presentation. Thank you for your time and your attention.